Hello, everyone. My name's Ciaran McNulty. I work for SymfonyLive UK, and I'm involved in a couple of testing tools. One is PHP Spec, which I maintain. I'm going to talk about this thing called a testing pyramid. I've just slightly reformatted my slides, so it might all break. What am I not going to talk about? I'm not going to talk about whether you should be testing your application. I have that conversation about 4 times a week because in my role I go and meet lots of teams and try and convince them to do TDD. I'm not going to talk about that today. You should be testing your application. You are testing your application. You might just be doing it in a really inefficient way. You might just be clicking on some pages and seeing if stuff looks like it still works. You maybe just deploy it to production and see if the telephone rings, something like that. So when we talk about doing testing, what we're really talking about is optimizing that process and doing it in less of a crappy way and doing it in more of an automated way that's going to save us time, because we do all eventually test. And the problem is when we want to start doing testing, there's all these different types of testing that you could possibly be doing, and all of these keywords: manual testing, acceptance testing, unit testing, integration testing. People talk about black boxes and white boxes. And if you draw them out in a Venn diagram, there's huge amounts of overlap. So I'm going to try and clarify what some of these terms are about and which types of testing you should be doing. And there's this other question. I maintain PHP unit. I talk to PHP Spec, yeah. Sebastian maintains PHP unit. I'll take it over one day. I talk to Constantine a lot about Bhat, and I get asked a lot, why should I use PHP Spec instead of PHP unit? Why is it better? And it's a really complicated question, because the answer is it's not. None of these tools are really the best tool to use. It's all contextual, and it's all about what problem are you trying to solve, which is going to be the best for you. You know, people get really frustrated. Why can't you tell me which of these tools will fix it for me? There's this really annoying coaching answer where you say, well, which tool do you think would be best for you? It just frustrates people, but the reality is it's a very complex situation. There is no best answer. It depends. You have to find out which tool is going to work to address the need you have right now. Or what type of testing are you going to do, because that will affect which tool you pick. And it's unlikely that you'll just pick one tool that you use for the rest of your career. That would be crazy. I'll talk about that in a sec. You can view these different tools as just different ways of optimizing this thing of, I need to know if it works. You could just click on stuff. You could just write a bash script that runs something and checks it works. You could just write some PHP that instantiates your objects and does stuff. All of these tools, this list of tools, are frameworks. In the same way that we could make a website ourselves, just make it using PHP, but it's a lot easier to use a web framework. You could do testing yourself. Matthias Varius has a testing framework that fits into a tweet. So these things aren't complex systems. It's not a complex subject. It's just there are different frameworks. And like choosing a web framework, you have to find one that thinks the way you think. And the framework of the talk is this idea of a testing pyramid, different layers of testing. It came from something Mike Cohn wrote about in Succeeding with Agile. And it's one way of looking at the different kind of testing you can do, the different ways you can test your application. And he identified 3 layers. The UI, integration or services, and unit tests. He may have said services. So let's go through the different layers from top to bottom. The easiest way to start testing an application, especially a web application, is to test its user interface. The reason for that is the tests will interact with the system the same way a human being would. They're going to open a web browser and click on some buttons and fill in forms and that kind of stuff. So it's kind of easy to see what the different use cases are. It's just like the route the user takes through the system. The problem with that kind of testing is that it's really sensitive to changes in the user interface. if the front-end developer edits the twig template, your test suite breaks. And the reason that's a problem is because user interface changes at a different rate to your core business logic. Your core business rules, the actual code, the stuff your system really does, changes when your business changes. Your user interface probably changes more rapidly. You probably just change the style of stuff quite often at a different rate to how you're changing the business logic. One nice thing about UI test is it's really easy to talk to a customer about the whole workflow, what's supposed to happen. And the really good thing about UI tests is it doesn't need the code to be any good because you're just interacting with it through a web browser. So it can be the worst legacy code base you've ever seen, but tests that go through the UI are going to be easy to apply. You don't even need to look at the code. You just need to look at the user interface and script interactions with it. I've put on the slide it's probably slow. The answer is UI layer tests are definitely going to be slow. That's a fact, because the web is a lot slower than instantiating objects. So you can do things to speed it up. People try parallelizing their tests and this kind of stuff. But fundamentally, UI tests are going to be slow, and they're going to break every time the UI changes. But they're very easy to apply without having to improve the code. So that's that top layer of the pyramid. The reason it's a pyramid is it implies that there's less UI tests. It's narrower at the top. They're slow. They're going to be hard to apply to the system. So the next layer, the service layer, it's about testing big chunks of your application, like big sections of your application, by calling methods, by testing services inside your system. It's much faster than UI testing, so there's probably not a web server involved. It's just in PHP. You're probably not using a real database. You're probably not using a real persistence layer. You're just instantiating a whole load of objects together, maybe getting them from the Symfony service container, get this service, call these methods. This stuff should have happened. So that can be a lot faster than UI testing. It also can if you've written the code the right way, it can be aligned with the acceptance criteria. So the test you're writing that sort of loads a service and calls some methods can look a bit like the conversation you had with a customer, especially if you've named that object correctly, you've named the method. Invoice approve, check it approves invoices. When I've already approved an invoice, it can't be approved again. That can be written in PHP as a service layer test. But there's an assumption there that you have services, that all of your logic isn't in the controller, for instance. So a service layer underneath your UI layer is going to add a lot of testing. You can test stuff at the service level and then not need to test it at the UI level. But it requires that you've built your application in a way that you have these nice objects that you can execute directly and aren't completely coupled in with Symfony. That's why a lot of people don't have these service level tests, if they're not used to that kind of architecture. And then down at the bottom we have unit tests. It's probably where a lot of people start, a lot of developers start with their testing practices, writing unit tests for one object at a time. The benefit of a unit test is you're only testing one object in isolation and looking at how it talks to the other objects. This is incredibly quick. It's just instantiating something and calling some methods and then throwing it away. So you can have a large number of unit tests, testing every aspect of each individual component. It's much faster, even again, than doing service level testing, because you're just doing one object at a time, thousands or millions of times. It requires good design. So the assumption here is that you have objects that you can instantiate and test, which I've worked on code bases where that is not possible. I used to work on a code base where if you instantiated an object, it automatically made a database connection. That's very hard to unit test. So unit level tests, it's almost like the guy in the factory measuring all of the nuts and bolts before we put the thing together. It's like you make sure every individual component works first. And then the service level tests can make sure it all works when it's put together. Like when we've put the engineer who puts the engine together, she can check that it actually works. So it's a pyramid because, I don't know if you've ever seen a pyramid, you have to have all the layers, you can't have the middle missing. It doesn't work. The top would fall off. So you can only have a small number of UI tests if you've got some service tests that are testing more comprehensively. You can only really rely just on service tests if you've got loads of unit tests. And the tests at the top are going to break more often. That's why you want less of them. You don't want to maintain them as much. It's rare for unit tests to break. That sounds ridiculous when I say it out loud. If you're doing it right, it's rare for unit tests to break. You change the test first, and then you change the object, and everything still works. It's really easy to break a service test. By changing one part of the system, another service might start failing, and that's why the service tests are there, to make sure everything works in a coordinated way. So stuff at the top breaks all the time in unexpected ways. I didn't mention it before, but UI tests also involve things like timeouts, like the web server doesn't respond in time, or the database connection drops while we're doing the test, so they can be kind of flaky. Unit tests are really reproducible. If you can instantiate an object once and run it, you can probably instantiate an object again and run it in a reproducible way. And there's a speed thing. We work with a lot of companies who say, I've got a test suite and it takes 5 hours to run. How can I make it faster? Do I need to buy a bigger web server? And when you look at it, it's typically that they've written tons of UI tests. That might be because that was the only test they could write because their code base doesn't allow them to do the other kinds of testing. But when you're testing at all of these different levels, you want to make this pyramid shape where you have lots and lots and lots of unit tests. Then you have as many service level tests as you feel like you need. Then you have a few UI tests. We'll talk more about that later. So that's that frustrating question, which tool should I use? It depends. It depends what kind of testing you want to do. And the kind of testing you want to do is going to be defined by what problem are you having right now. So the way a lot of companies start doing testing is not that they saw an amazing talk about BDD or test-driven development. It's that stuff breaks all the time and we want that to stop happening. So we keep having bugs, these regression issues, and we just want an alarm to go off when one of them happens. That's called regression tests. And it's often the way you start doing testing. Now, the secret is all tests actually become regression tests eventually. So if you're doing all the other kinds of testing, after you've written the test, it's going to stay around. It's going to act as a regression test for the future. But maybe you just want to directly write regression tests. The easiest to apply at the UI level because it's not going to require you changing the code. They're just going to check that a particular behavior still, in the UI sense, still occurs. And you've got to remember that because if you do it at the UI level, they are going to break constantly. You're going to have to take the hit of maintaining this set of tests. They're going to be slow to run, and they're going to break. But maybe that's what you need right now. So this is some legacy code. I thought I'd show an example of modern legacy code. So it's a Symfony application. The reason it's legacy, in my opinion, right now is that there is logic here in the controller. It's kind of hidden, but the act of adding a product to a shopping basket, it's like you ask the basket, give me your list of products, and then you modify it in the controller, and then you push it back into the basket. So that basket isn't really responsible for anything. You're just treating it like somewhere to keep products. And maybe my whole code base is like this. It's going to be hard for me to write unit tests around this behavior that actually mean much. It's not using services, so the stuff is directly in the controller. I'm not going to be able to really write service level tests. And if I don't want to get stuck into that, if I don't want to try and improve the code base right now, I'll have to write UI-based tests. And there's different tools you can use. One is PHP Unit. PHP Unit is a really good choice for a testing tool if you only want to use one tool. And if you're just starting doing testing, that might well be what you want to do, because PHP Unit by design can write any kind of test. You can use PHP Unit for unit testing. Confusingly, because it's called PHP unit, you can also use it for any other kind of testing. And Symfony ships with a set of components that make it easy to do UI tests. So PHP unit can use these components to drive your UI directly. So here we're extending the web test case, and this is a kind of UI test. It's not expressing business behavior or anything like that. It's not, we haven't written it, we probably haven't written it before we wrote the code, let's be honest. It's something we bolted on afterwards, so we can run it, and if that thing doesn't happen anymore, adding a product to the basket, this test will fail and tell us. So like I said, PHP unit is great if you only want to use one tool. You can also use Codeception, which I think uses some of the PHP unit stuff internally. Tries to make it a bit more expressive, easier to write. So if you're trying to write a ton of regression tests, this might be a style that works for you. You can also use bhat and Mink extension in a way that bhat purists will say, oh, that looks terrible. But actually, this is a nice, simple, domain-specific language for writing automation, browser automation tests. Don't worry, I will show an example of the right way. But you know, if you want to churn out a load of regression tests for an application, you can write a file that looks like this and cover your application and find out where stuff breaks. You've just got to be you've got to know going into it that this is going to break a lot. Every time we change the path, every time we change the text on the page, this will break. Or you can outsource it. So this is just one tool. I'm not particularly endorsing them. It's just a tool I'm aware of, but they seem okay. So Ghost Inspector is an example of a set of tools that just automate this for you, and you don't need to write any code. Selenium IDE is an older tool where you can just record, you just interact with the website, you record the clicks you're making, and it just records what you clicked on and reruns it, and checks the behavior is still the same. Ghost Inspector is like a cloud-based thing that continually tests your site. And that's a good choice, because maybe you don't need to write code for this. The kind of tests we're talking about are just UI interaction scripts. So having some tool that can record that makes perfect sense. So pick a tool that works for the team you've got. Are they going to be technical people writing the tests? Are they going to be people who already know PHP unit? Perhaps. Plan to get rid of them later when the code base improves. Treat it as a stopgap, except it's going to be slow. Probably lean towards testing end-to-end because you'll get a lot of coverage quickly. And just understand it's going to be hard to maintain. So that's how people start doing testing, but it's like the worst kind of testing. It's going to be a nightmare to maintain. But it's better than not having tests. Perhaps your problem is not random bugs happening everywhere. Perhaps your problem is that we keep building the wrong thing. And we only find out after 4 weeks that we built the wrong thing, and it's not what they wanted. You have that's not what I wanted conversation. So this is a different sort of style of testing. It's more about acceptance tests. I want a test. It's not about detecting random bugs that have popped up. I want a test that tells me whether the thing I've written does the thing the customer wants. Which you can think of, it's almost a completely different kind of test. So we check that the system does what the customer wants. They're aligned with the customer's language as much as possible. So you write your acceptance tests after talking to the customer and having a conversation about what it should do. You write them in English or your native language first. So you have the conversation first, and then you're going to sort of translate them into code. And they can be tested at the UI level or the service level, depending on whether you have services or not. You can't apply acceptance tests to objects, individual objects, because you can't say to a customer, what should this class do? That doesn't make any sense. So you're normally testing at this service level. So start with a conversation where you're asking questions. You're talking to the customer. You might be in a situation where you never meet your customer. That happens a lot in development teams. Maybe you can change that somehow. Fight to get access to the people who actually need this code base. And talk about examples. What should it do? So what should happen in this case? That kind of questioning. Have that conversation before you start working on it. don't have the conversation too long before you start working on it, because you'll make an agreement and then 6 months later start working on it, and it's not what anyone wants anymore. It's not actually what's going to solve the business case anymore. So have it sort of just in time. If you're doing sprints or something like that, have a conversation before sprint planning where you talk about what it's supposed to do. So what should the system do when this happens? Does that always happen in that case? Are there some other considerations? Like, does everyone pay that price for that product? Or do some people get a discount? Or is it a sale on a Tuesday? It's a good way of discovering extra edge cases. What assumptions are we making that causes that outcome? What other outcomes are there? So we've talked about one scenario. Is there anything else that happens? Like maybe an email has to go to someone as well, that kind of stuff. What if, what if? It's amazing to have testers in these conversations because they're good at that what if part. It's vital to have business experts in this conversation because they're amazing at that requirement delivery. They explain what the problem is. And you have to have developers there because they're good sort of solution people. And then you write out your conversation. If you don't start doing this and you just start having conversations with your customers, that's a good outcome. But then maybe you should write down what you talked about. And try and make it look like the conversation you just had. And how successful that is will depend on the tool. It's probably easiest to test through the user interface. So this is what I would do if I had to use PHPUnit for this. There's no sort of natural tool for it, but the technique you can use is to try and extract the automation bits. So that messy URL-specific code, the messy text-specific code, I'd extract it into private methods. And then in the test case, I'd just be calling those private methods. And I'd be naming those private methods to match the conversation I had with the customer. In codeception, you can't quite separate it out as much, but you can add these extra lines, I expect to, that adds text content, and when you run codeception, it will output those as the test is executing. So it's kind of like a comment almost, but it's just explaining what the business case behind this automation code is. If you use Bhat, you can just write it in English, which is quite nice. And then you run it, and Bhat says, I don't know what any of this means. So you have to explain what this stuff means. So the way you do this in Bhat is to write these are called step definitions. I won't go into the details of where they live, and they have a kind of pattern matching. So you have the English text that explains the conversation you had with the customer, and then you have this step definition that says that English text means this messy automation stuff. Hopefully that made sense. If you do have code that uses services, this is the same code, but I've moved the logic into a service. The basket is kind of a service at this point. We're asking the basket to add a product. I can then start to, the implication is the basket has a lot of stuff behind it. It's not just one object. It's maybe also storing things and sending notifications. In this case, I'm also going to be able to test the acceptance test at the service level. So I still have the same conversation with the customer, but instead of testing it through the UI, maybe I can test it by running some PHP code, which is going to be a lot faster. It's a pretty small change. So in PHPUnit, then I can directly instantiate the basket with whatever dependencies that object has, and I can directly test it. I'd still try and match the language used, the test adding product to the basket. I'd still try and match the business language that was used in the conversation I had with the customer. More interestingly, with Bhat, you use the exact same expression of the business language in this Gherkin file, and you just write a different mapping from that same language to direct service tests. What makes this really interesting is you're decoupling this process of writing a test. You're writing a test with the customer in English, and then later you're writing the automation part of it. So you're sort of getting the outline of the process with the customer, and then the messy stuff they don't need to see is in a different file here. So instead of doing browser automation code, I'm just directly exercising those objects. This ability of BHAT, which was introduced in BHAT 3, to have 2 levels of testing in parallel, called suites, enables this idea of, well, if I've got all these business cases written out, and I know that all of the services work, how many of those horrible, slow, hard-to-maintain UI tests do I need to write? Do I need to test all of the business cases again through the UI? So you start to regard Symfony as like something that's invoking your application. So when you've got a games console and you know the console works, and you plug in a controller, you just press 1 or 2 of the buttons. And if something happens, you know it's working, you know it's all plugged in together correctly. You don't feel like you have to press every action and check the console does the right thing. When I get a new keyboard and plug it into my computer, I just sort of go, and as long as some text appears on the screen, I'm happy. So Symfony is the web integration for your services. So we don't need to then test all of the business cases again through Symfony. We just need to check Symfony's plugged in to the service layer. So if you've tested everything with services, and that's a big if you've got that middle slice, then you don't need to test everything again through the UI. You can choose a subset that will confirm your UI is plugged into your service layer correctly. So here's an example of a few different scenarios involving adding products to the basket. If they've all been tested through the service layer, so I know that products can be added to the basket, I know that I can't add a product that's already there, and I know that if I add 2 products, both of them are in the basket. Really at the UI level, all I need to check is that the things that are in the basket are being shown in the template, and that the Add to Basket button is hooked up to the method that adds things to the basket. So I only need to test 1. I can tag just 1 of these scenarios and tell the tool, run all 3 of these scenarios at the service layer, and just run this 1 at the UI layer. We don't need to run all of the others. It would just be a waste of time. And there's some configuration that you can do. So that's acceptance testing. The key thing for acceptance test is that point where you talk to the customer about it. And you have the conversation not in terms of UI, what should the button be called? You have a conversation in terms of what should this feature do? If you try and write functional tests yourself, you're effectively going to be writing regression tests, like we talked about before. You're going to be capturing the behavior that exists there right now and just checking it doesn't change. So maybe neither of those things are your problem. Your problem is that your actual object-oriented design is terrible. If that's the problem you want to solve, you should start writing unit tests. And there's a pro tip. Write them first. It's amazing. So why does that make your code better? It's because code that's badly designed is really hard to test. So if you write the test first, you can't write bad code. You can only write good code. So unit tests, what are they? They're checking that a particular class does the right stuff. They can't be driven by acceptance criteria. You can't have a conversation with the business, what should this object do? Doesn't make sense at all. You should move towards writing them first. I could be really zealous about it and say you have to, but the reality is a lot of people in their journey towards testing start by writing them afterwards and then later start writing them first. So just start doing unit testing. And it's going to force you to design things well. Just because it's just really painful to test bad code. It's really easy to test good code. So it'll sort of incentivize you or nudge you towards always writing awesome code. You can't ask the customer. The customer's only got the big picture. The engineer responsible can't. is responsible for all the little nitty-gritty details. So unit tests are written by the developer. Unit testing in PHP unit is pretty straightforward. You instantiate an object. You can use mocking to simulate the other objects that it's going to speak to. Other mocking libraries are available. It's pretty straightforward. You just think, well, what's an example of something this object should do? I'll write a test. So here we're saying, when I ask it for the products, it should get them from the storage object. When I ask it to do something, it should ask the other object for some stuff and give it to me. Very simple. Same test in PHP spec. This is the first time we've seen PHP spec because it is not useful for integrated tests. It's not useful for service layer tests. It's not useful for UI tests. It's just for unit testing. Because it's just for that, it's a little bit less verbose than the PHP unit, because PHP unit has to also cater for all those other types of testing. PHP spec, we can take some shortcuts, because we just know you're doing unit tests. So here we say it's constructed with the storage object, add the product. This method on the storage object should have been called. So unit test the code that's responsible for your business logic. That core idea of a domain model, we have this idea of MVC, and everyone kind of forgets about the M. There's meant to be some PHP code that you wrote that isn't Symfony-specific code, that Symfony's talking to. So try not to worry too much about unit testing code that interacts with Symfony. You can unit test your controllers. I think there's a use case there, but don't feel like you have to. And you don't have to unit test, your param converter, that kind of thing. If you've got UI tests, they'll pick up any crazy problems that you introduce. You can start regarding that Symfony integration as just the UI layer of your application. The core is these objects you're writing that express your business. Yeah, I just said that. So we've been talking about chopping off the top layer of testing, the UI layer, and just testing from the top down. There's another thing that makes service level tests slow, which is that often they have to interact with infrastructure, maybe a database, or talk to some web services, or put stuff in cloud storage and all that messy other people's problem logic. Something like this. So I've got a validator that validates a file. I've got a file handler, because I'm bad at naming, that handles files. And I'm talking to some cloud API, some third-party API, probably Amazon, realistically. Someone like that. And that's storing in cloud storage. Or maybe I'm talking to something like Fly System that wraps different cloud storage providers. But either way, I'm talking to some code I didn't write. I'm talking to an interface that someone else designed. I'm talking using a contract that someone else wrote. Right. And you can write unit tests for this stuff. This is an example. It's based on a real example from my life, where I've got this cloud API object that someone else owns. I downloaded it from Packagist. I'm using it in my code. And I'm saying if you construct my file handler, this is PHP spec, by the way. If you construct my file handler with the client and the validator is going to say yes when it's asked to validate something, these three methods on the client should be called. So this is describing how my object is going to talk to this third-party object, and it will return true. And there's something missing in the test, which is, and also probably there should be a file in the cloud storage at the end of all this interaction. And that's not something unit tests capture, so there's a kind of missing element. This happens a lot when you're talking to infrastructure. You're not capturing all the important detail. So I wrote a test like this. It passed. I was happy. And then when we looked at that green passing test, I still felt, I don't know if this works. I don't know if running this code is actually going to create a file on this cloud storage provider. So we wrote integration test. And shockingly, it failed. There wasn't a file on the cloud service provider. There was a fourth method you had to call that we'd missed in the API called like finalize upload or something. Which, well, you could just be thinking, well, you should have just got it right. You're an idiot. But the lesson there is that the reason we made the mistake is we're having to understand someone else's interface to write this test. We've captured a whole bunch of assumptions about how this other code wrote, but it's not something we control. That's where the problem has happened. So when you write this kind of test, you can write this kind of test. The tools will allow you to. Whenever you write a test like this, you probably are also going to end up writing an integration test that checks whether it actually works. And at that point, you might think, why did I bother writing the unit test? It didn't add any confidence to me. But there's some other aspects of the object that I do want to unit test. I want to check that it listens to the validator. I want to check that it tries to upload a file. I accept that I can't check that it actually uploads the file, but I want to check that I still want to check the logic inside my object. This is the problem we have. We have two sort of domains here. We've got my core business model, and it's talking directly to someone else's design, and there's an overlap. The object we're talking about is in this gray area between the two. That's what's making it unsatisfactory to unit test it. And the solution really is to shift to more like a layered architecture. So I want to isolate my domain model completely. I don't want objects inside my domain model to ever talk to any object that isn't in my domain model. Which sounds tricky, but we have this amazing thing called object orientation and interfaces that let us achieve this sort of seemingly magical trick. So instead of having my file handler directly talk to the cloud API, I'll introduce an interface here. So what I'm introducing is a contract that I own. So I know what store means. I've created this concept that storing a file is a thing, and that is a concept in my domain. There are places called file stores where you can store files. I am really bad at naming. But in reality, it needs to hook up to a cloud API, so I'm going to have to write an adapter here. I'm going to have to write an object that implements the interface I designed and talks to the cloud API that I'm interested in. It sounds like an overhead maybe, but this separation allows us to clarify exactly how we're going to test this stuff. So I can unit test all of these objects at the top that are part of my core domain. So I can unit test everything that's in my domain model because they're not talking to third parties. I'm not going to have that problem of knowing whether it actually works or not. But then I have to know, does this bit work? So this is the unit test I would write. Instead of constructing it with some third-party object, I'm actually creating a double of my interface. I'm saying there's going to be something that's a file store. And when the validator says true, and I ask you to process a file, you should store it in whatever file store we're using. This means I can unit test my file handler. I know 100% that my file handler is doing the correct thing. What I don't know about yet is whether these objects are doing the right thing. Are they actually going to store a file on, I'll say Amazon? Are they actually going to store a file in the cloud? The only way I can really test that is by doing the thing and checking there's a file there. So I'm going to have to write a slower test. And you can call it an integration test. Integration tests are a slightly vague term. I'll try and call it something like an infrastructure integration test, where we're going to test this whole thing. We're going to instantiate a cloud file store that implements the interface. We're going to give it a real cloud API. We're going to hook it up to a test account. And we're going to test that when I call store with a file appears in the remote service. It's harder to write. You have to understand the cloud API. It's going to be slower. But you're checking that you make the real cloud API, You ask it to upload a file, and then you check the file is there in the storage. The reason we've separated them out is so we can treat them separately. Maybe we run them at different times. Maybe you only need to run this one when you've made some changes to the cloud storage. Whereas the unit test, you want to be able to just hit the button and run the tests, and it takes less than a second to execute the whole suite. And to be honest, if you've got acceptance tests that cover that, you maybe don't need the integration test. So it might be enough that you have an acceptance test that runs with the cloud API. Similar to the UI, you want to think, what subset of these acceptance test cases, maybe I'm testing the entire service layer with a double of the file store. How many of these do I need to run with the real file store? I don't need to run 200 different business cases, all of which store a file in the file store as part of a bigger interaction. If one of them works, then I'm pretty sure the file store integration works. Maybe there's 2 or 3 different ones we need, one that handles an error, one that doesn't handle an error. When you have acceptance tests, you can look at phasing out your integration tests in favor of another suite of acceptance tests that tests your business case with that infrastructure attached. So to recap, to build that pyramid, firstly, have unit tests. Make your design good. Write your tests first and test every little component as it works. And you can have thousands of those, and they will run very shortly, very quickly. Your unit test suite will typically take a few seconds to run. Architect your application so it has a service layer. So not all your logic's in the controllers. You've got objects that are responsible for doing stuff. If you're in the DDD workshop yesterday, we talked about some ways of doing that. Once you have that layer that you can test directly using PHP, you can write acceptance tests against it. So you're checking it does what the customer wants. You're also checking the services behave correctly. And a service-level testing suite will take minutes to run. Maximum. And then once you've tested everything at the service level, you can have this rational conversation about how many of these do we need to retest through the UI? How many of these do we need to retest with Symfony involved? Probably not all of them. And the fewer UI level tests you have, the easier the suite's going to be to maintain and the faster it's going to be. Because they take minutes each to run sometimes. It's very hard to write a UI level test. It's okay with BrowserKit, but you can often find that just bootstrapping the whole application is going to take a few milliseconds. Running a big test suite of UI tests is a recipe for pain. The only way you can get away with not having a lot of UI tests is having that service layer testing and the foundation of unit tests. So that's it from me. I think we're quite short on time. Can we take any questions? We can have one question or maybe 2 if it's a short one. No one has any. Yes?
Would you write unit tests for the class adapter as well?
Would I write unit tests for the class adapter? No. For the same reason, the class adapter is talking to some third party. So I'm never going to know if it's doing its job correctly unless I have write an integration test. There is a slight edge case. If you're really into TDD and you can't write objects without tests anymore, you can write the unit test. Just don't kid yourself, it's a good test. So like PHP spec does some nice stuff where it generates classes for you. If you want to take advantage of that, you can write a test first. But it's not, you have to write the integration test as well. Yeah.
Do you have any suggestions for when you don't actually own or don't have any control over the third party and you want to test the file store, that bit that actually connects to it, to actually write those integration tests?
If you don't have access
that
to...
becomes, well, you don't have the usual way they would usually have to, let's say, dump data in a database during your integration test, as you would. For instance,
So you're asking about like how do you get access to a thing you can set up in different ways for different kinds of tests?
Is there anything that probably make it faster, easier, or...
No, there isn't, unfortunately. So was asking about if you're interacting with a cloud API or something, it would be nice to have quick ways to like set it up into a particular state before your test, that kind of stuff. And it just varies per provider. So you've got to try and pick one that lets you have a good test account. Or you have to script adding loads of things and taking them out again. And that's why these kind of tests are painful. That's why.
Your assumption is that those scripts are actually working for you all the time as well.
Yeah. There's a lot of assumptions, but I mean, ultimately working with third-party services is full of assumptions that it's going to work. You can't get away from that. I think that's, are we out of time? Yeah, I think we're out of time. So I will be around all day. If you've got any more questions, come and find me. And thank you very much.